Okay, so we've got a best by question here, and usually with best by the best thing to do is work out what one of something is. As this is about millilitres of toothpaste, we're going to work out the cost of 1 millilitre for each tube. So the first one we're going to do 109 divided by 50 mils. So 0.0218, and we must remember the units of that is pounds per millilitre. Really important that we put the units down so we can see what we're doing. So 168 divided by 75, so 0.0224 pounds per millilitre, and then we've got 269 divided by 125, and 0.02152 pounds per millilitre. Okay, so with best by problems then, quite often the best thing to do is to find out the cost of one thing, one item, so you can compare like with like. And here we can see that 0.02152 is the cheapest price per millilitre, because we've got an 8, we've got a 5 here, that makes it cheaper. So basically we're going to conclude 125 millilitre tube is cheapest, so best by. Okay, you might want to put in there cheapest per millilitre just to confirm what's going on. So that's that question sorted. This question involves a scale, so it's going to be about using compasses and ruler, because they're giving you some rules and they're telling you some conditions. So basically we need to think about this. Photocopy is going to be right, it's closer to B than it is to A. Well, what we need to remember is that basically if we look at what that is telling us, we've got 2 points, A and B. We want the line in the middle, and we want to be closer to B than it is to A. And to draw the line in the middle of 2 points, we need to draw what's called the perpendicular bisector. So the perpendicular bisector between 2 points is drawn by opening your compasses over half the distance. So we can see this between A and B. So open your compasses over half the distance, draw roughly half a circle one side, and then go to the other point and create the intersection points on the original arc. Highlight where the two intersection points have crossed over, and then draw the line through those 2 points. So basically all the points that are this side of the line are going to be closer to B than it is to A. That's that condition done. It then says that we want to be less than 8 meters from C. Well, we go to the scale and it's saying 1 centimeter to 2 meters. So 8 meters is going to be 8 divided by 2, so 4 centimeters. So we get our ruler, and making sure our compasses are tight, so use a screwdriver if you need to. Open them up to 4 centimeters. And again, be really careful on the accuracy. It says from point C, so we put our compass point down and we draw the arc. Now remember, with compass questions it's really important you don't rub anything out. Leave your construction lines on to make sure you get the method marks. Okay, and basically it then says show by shading the region where the photocopier can be put. Well, it has to be less than 8 meters from C. Well, that's our 8 meter boundary, so it needs to be in here somewhere, and it has to be closer to B. So basically we're talking about this region here. So as long as we're kind of clear, don't have to spend ages shading the whole thing really thoroughly, but we just have to be clear that we're choosing that region. Okay, so watch for these kind of questions involving compasses and look for key ideas. This one says from C, single point, so we knew that we were going to be drawing a circle or part of a circle around that single point as a boundary. Okay, so this next question talks about finding a missing angle. So we've got parallel lines, we can see the arrows, so straight away we should be thinking of alternate angles, corresponding angles and co-interior angles, and the parallel lines forming the boundaries for those. And we can see that if we follow this 76 degrees, then we can create a Z where the whole of this is 76 degrees. The question does say give reasons for your answer, so as soon as you put something onto the picture, then give the reason. So this is alternate angles are equal. And there's no harm in putting your reasons around the picture, because the examiners have got to look around all your workings. As long as you stay within the working box, then they will look to see whether they can give you the marks. We know this is a triangle, and we know the angles in a triangle add up to, so if we work out this bit here by doing 180 degrees, take away 90 for the right angle, because we know this is 90 degrees, take away the 54 degrees, so we got 36 degrees left. So we know this bit is 36 degrees, and we'd have to give the reason, of course. So angles in a triangle add to 180 degrees. And then we've got x, so x is going to be the 76 degrees for the whole of this angle, take away the 36 part that we just found, so 40 degrees. Okay, so answering questions involving angles, then make sure you know your reasons. If you see parallel lines, then think of your alternate, your corresponding, or your co-interior. Follow angles round, see what you can trap, and then write the angles on the picture. Give your reasons around the picture, it's not a problem. And hopefully it should be a fairly straightforward question. Okay, so this question talks about polygons, and it's mentioned the word pentagon, hexagon, it's mentioned the word regular. So all the time when we see questions on polygons, we should be thinking of interior angles and exterior angles. And remember, the interior angle is formed by two straight edges of the polygon, because the polygon is a straight-sided shape, and the exterior angle is by extending one of the edges and making 180 degrees with the interior angle. So the exterior angle. And for regular polygons, we have a simple rule, that's the exterior angle equals 360 degrees divided by n, the number of sides, or number of edges. And for all polygons, then there is a rule for the sum of interior angles, and that's n take away 2, n again being the number of sides, times 180 degrees. And that comes from the fact that, for example, if you've got a pentagon, then we can see that we can create 3 triangles as the minimum, and each of those triangles has 180 degrees. 5 take away 2 is 3, 3 times 180 tells us we've got the 3 triangles within there. So with this question then, the first thing I'm going to do is work out the exterior angles. So for this one here, it's going to be 360 divided by 5, so 72 degrees. The exterior and interior add up to 180, so that'll be 108 degrees. So we already know that it's regular, so that means every angle is the same inside this pentagon. And we do the same for the hexagon, so if we work out this angle here, then we know it's 360 divided by 6, which is 60 degrees. And then the other angle must be 120 degrees, because the interior angle and the exterior angle add up to 180, and every angle inside the hexagon is the same because it's regular, so this will be 120 degrees. And the question wanted the angle EAF, and what we notice is that the line EA and EF are equal because the pentagon is touching the same length on the hexagon. So we know that those two lines are equal, so we have an isosceles triangle. So basically, if we just sketch out the triangle, then we've got E, A and F, and the question wants EAF, it wants this one. And we know in an isosceles triangle that base angles are equal, so these two angles will be identical. All we need is the angle here. Well, we can see from here that angles around a point add up to 360, so angle AEF is equal to 360 degrees, take away 108 degrees, take away 120 degrees, so 128 from 360. So 360 take away 128 and take away another 100 because it was 228, so 132 degrees. So we know this angle here is 132 degrees. Because we know base angles are equal, then the angle the question wanted, so angle EAF is equal to 180 degrees, take away 132 degrees, all divided by 2. So 180 take away 132 equals divide by 2. So 24 degrees. Okay, so just do a quick check. So 360 minus 108 minus 120 equals, take away the 180 equals, divide by 2 equals 24 degrees. Okay, so that's how that question could be done, thinking about angles in polygons and the rules around those. This next question is again looking at polygons. It's telling us that we've got regular polygons. So again, we can work out the exterior angle by doing 360 divided by 6 because it's regular. So that means that angle there must be 120 degrees because the interior angles are all the same. And this one here, it's an octagon, 360 divided by 8. It's a regular octagon, so 45 degrees. So this will be 135 degrees. So we know that that'll be 135 degrees as well. And we've got angles around a point. So it says you must show all your working. So we're doing that around the picture. And then we're going to say that x is equal to 360 degrees minus 135 degrees, take away 120 degrees equals, so 360 minus 135 minus 120 equals, so 105 degrees. It says you must show your working. Well, we've done the working. It didn't say give reasons for your answers, so we didn't have to write down exterior angle of a regular pentagon equals, all that kind of stuff. But we've shown all the clear working for the solution to this question. Okay, so this question involves a right angle triangle, and it involves two lengths, and it wants to find a missing angle. They're calling it x, so I think of it as theta for any angle. And once we know it's a right angle triangle involving lengths and angles, then quite often it's about trigonometry. So Tower helps us to remind us which of the ratios we're going to use. So there's the angle that we're working with. So this must be the opposite side. This is the hypotenuse. This is the adjacent. We know the opposite side and the hypotenuse side lengths. So O and H is known. H is known, O is known. This is the one we've ticked twice, so it's telling us to use the sine function. So the sine function is the sine of theta, the angle, is equal to the opposite length divided by the hypotenuse length. And you've got lots of ways of doing this, but basically when you want an angle, we do the opposite of sine, which is the inverse sine, sin to the minus 1, of the opposite length and the hypotenuse length. So it'll be sin to the minus 1 of 5 over 14 equals. So make sure you calculate this in degrees mode. There's a D there, and we're doing shift sin minus 1 bracket 5 divided by 14 close bracket equals. So 20.9 degrees to 3 significant figures. Okay, so this next question involves triangles, right angle triangles, so that'll be a right angle as well. And it's telling us that ADC is a straight line, so those two will be right angles. And it's got lengths and angles, so it's shouting out use trigonometry to work out missing lengths. It wants the length of AD, so this is our mystery length. We'd like something about this triangle to help us find it, but at the moment we only know one length, so we need another length, and BD will be the length to find. So BD is involved in this triangle, and we can see that this triangle involves a length and an angle, so it's going to be trigonometry again. So Tower. That's our theta, the angle that we're working with. So this must be the opposite length. The longest side is the hypotenuse, and that's the adjacent length. And then we ask ourselves, well, what does the question need? Well, we need to find O, so we must involve O in one of the ratios, and we know H, so, and that's the one we've ticked twice, so we can use the sine function. So the sine of theta is equal to the opposite length over the hypotenuse. Now when you want a length, the triangle for the sine cosine functions is quite useful to decide on which letters go where and how you rearrange. So let's have a look what we're told. Well, we're told the angle we're dealing with is 40 degrees. We're told the length of O is BD, and we're told what the length of H is, 16.4. We want the length of BD, so we're going to move this across here. So BD was O, so when we cover up O, we can see that these two are next to each other, which means we're going to be timesing. So it's 16.4 times the sine of 40 degrees. So 16.4 times the sine of 40 degrees, close bracket, equals 10.54. The question wants the answers to 3 significant figures, so until we get to the final answer, then do at least 4 significant figures. So that's the length of BD, and then when we look at the triangle we're working with for AD, then we found that's 10.54, we found this is 12.2, so this is kind of a right angle triangle, 2 lengths given, we need a third length. It's kind of shouting out, please use Pythagoras. So Pythagoras' theorem says that the 2 short sides, the length of those squared and added, must equal the length of the hypotenuse, the longest side squared. So we've got AD squared, because no AD yet, we've got B squared, so that's 10.54 squared, and that equals 12.2 squared. And so AD squared, we're going to have to do a takeaway here, because we want a short side. So, and then we're going to find that AD is equal to the square root of that. So on our calculator then, square root of 12.2 squared, take away 10.54 squared, equals, so 6.14 to 3 significant figures, so 6.14. The question was in meters, so put your units down always with answers. Okay, so that's how that question was sorted, by thinking about right angle triangles, lengths and angles, trigonometry, and then we had another right angle triangle with 2 lengths given to find a third length, which shouts out use Pythagoras. Okay, so now we've got some ratio practice, and so this question talks about the amount of money Kim and Laura may share. Right. So okay. So we've got some. So we've got Kim, Laura, and Molly. They're telling us that the ratio of Kim to Molly is 2 to 5, and we're talking about the difference in the amount of money they get. So in blocks of 2 and 5, then for every £2, Molly gets 5. So that's a difference of 3. The question tells us that we've got a difference of £105 at some stage, so that means we must have got so many multiples of this starting ratio, and when we do 105 divided by 3, we get 35. We'll just do a check. 105 divided by 3, 35. So that tells us our multiplying factor then will be 35. So Kim's working with £70 and Molly's working with 535s, 150, 175. A quick check, the difference between those two is £105, so we seem to be okay. Now there was a total of £385, so to get Laura's we're going to have to do 380, take away the one, oh sorry, not 380, it's 385, so 385, take away the 175, take away the 70, equals. So Laura gets £140. Okay. The question wanted what percentage does Laura get. So the answer line's got a percent sign on it, and so percent is always equal to a fraction times 100. That's the best way of thinking about percents to me. And we always put the original amount or the total on the bottom of the fraction, the denominator, and on the top goes what we're talking about. Well, this time we're talking about how much Laura gets. She got 140. So we then do that calculation on our calculator. So 140 over 385, come away from the fraction, times 100 equals, change that to a number, so 36.4%. So 36.4%. Okay, so that's how that question could have been done. Question 2 in the ratio practice. It talks about Talil. It's going to make some concrete in this ratio. So again, I always recommend ratio problems that you write the headings. So cement, sand and gravel. Put the ratio bits you know, so 1, 3 and 5. This time we're talking about the totals of the mix. So we've got 9 parts. So for every 9 parts, of the mix, of the concrete mix. There's 1 cement, 3 sand, 5 gravel. It wants to make 180 kilograms, so we need a total of 180 kilograms. So the multiplying factor here is 20, so that means we're going to need 20 lots of each of these. So we're going to times by 20, so we need 20 kilograms of cement, we need 60 kilograms of sand, and we need 100 kilograms of gravel. Does Talheel have enough to make the concrete mix? So basically, does he have enough? Well, we can see that cement, there's only 15 kilograms. Our issue is we need 20. So the answer to this question will be no. Talheel is short by 5 kilograms of cement. Okay, so no, he doesn't. He's short by 5 kilograms of cement. The next question talks about Colin, Dave and Emma sharing some money. Colin gets 3/10 of the money, Emma and Dave share the rest of the money in a ratio of 3:2. What is Dave's share of the money? Okay, so Colin gets 3/10 of the money, so Emma and Dave share the rest, so that means there's 7/10 left to share. So Emma and Dave share the rest of the money in the ratio of 3:2. So we've got 7/10 between Emma and Dave. So basically we've got Emma and Dave ratio of 3:2, and we've got total parts of 5, but we want to work with 7/10 shared in that ratio. So 7/10. So we're going to have to do 7/10 divide by 5 to find the multiplying factor. So we multiplied by 0.14. So we're going to have to multiply by 0.14. We're only interested in Dave, so Dave gets 0.28. And 0.28 is, it says, what is Dave's share? So we could leave it as 0.28, 28%. But as we was dealing with a fraction, then we can do 28 over 100. And then again, we've got a calculator paper. So 28 over 100 equals, so 7/25. Okay, so Dave gets 7/25 of the money. Okay. There are only red and green beads in the bag. The ratio of the number of red beads and green beads is 5:9. So we've got red beads and green beads, ratio of 5:9. So the total parts is 14. So it says what fraction are red? Well, 5 out of 14. There's a total of 84 beads in the bag. How many beads are green? So we've got the situation of red, green, 5 to 9, total of 14 parts per section. So we're dealing with 84. So 84 divided by 14 is 6. So the multiplying factor is to take every part and multiply by 6. So there's 30 reds to 54 greens. Add those up to check, adds to 84. The question says how many beads are green, so we must finish off by writing down the answer. So 54 green beads. The question goes on. Susie's going to put some more beads in the bag. There will still only be red and green. Okay. Susie wants to have twice as many green beads as red beads in the bag. Okay, what bead should you put in the bag? Okay, so we had a situation where red to green was 30 and 54, and that gave a ratio of. So Susie's going to put some more beads in the bag. There will still only be red beads and green beads. And Susie wants to have twice as many green beads. Okay, so twice as many green beads. So 35 and 70. That makes sense, because then there'll be twice as many. Okay. So we're looking for twice as many, so we need double the amount of green than red. and we had 54 to start with, so I basically looked at numbers going up from 54 where it had to be bigger than 30, doubled, which was 60. So I counted up from 60, and then 60 could be 30. Ooh. Okay, so I could do that, but I could also do 60 and 30, because 30 would be in the bag, and if I just had 6 more green ones, then I've got twice as many green as red. So that'll be the smallest quantity to add in. Either of these answers would have been fine, but I'm going to do the smallest one. So 6 more green, and then that'll give us a ratio of 1 to 2. Okay, so 6 more green added. Okay, so we've got a question now that goes on and wants us to interpret a Venn diagram to complete probability. So this is for who chooses Latin. Well, Latin is the whole of that circle. So there were 8 people who chose Latin out of a total of 8, 16, 20. So 8 out of 20. So that means 12 out of 20 did not choose Latin. For Spanish, it's this circle here. So that's 13. That's going to be 13 out of 20. So that'll be 7 out of 20. 13 out of 20. 7 out of 20. Okay, so that's completed the Venn diagram from the tree diagram, or the tree diagram from the Venn diagram, I should say. So a student's chosen at random. Work out the probability that student does not study Latin and does not study Spanish. So does not study Latin, does not study Spanish means we're down here. So when we come along trees, when we're doing probability, we take the 2 probabilities in this case because there's 2 branches we followed, and we always multiply the results because they're independent. So we multiply these 2. And we end up with 84 over 400, and we could cancel that down as we've got a calculator, so 84 over 200 equals 21/50. Always write down your intermediate steps there, just in case you make a mistake. Okay, so that was filling using a Venn diagram to fill in a tree diagram, and then once we got the tree diagram filled in, we were then able to work out the probability. Okay, so this next question talks about having 2 different pencil cases, and in each pencil case there's a variety of things. We're going to take 1 pen out of each pencil case, complete the tree diagram. Right, so out of the round pencil case, probability of getting blue is 4 out of 7. So the probability of getting red will be 3 out of 7, because these probabilities come from an event, must add up to a whole one. And for the square pencil case, there was 3 blues and 5 reds, so the probability of getting that was 3/8. So the probability of that one is 5/8, 3/8, and 5/8. Okay, so that's the tree diagram filled in. And then we have to work out probability that the pens she takes out are both red. So basically we want red first time followed by red second time, so we're down here. That means we've picked up 3/7 and 5/8. Because these 2 probabilities are independent of each other, whatever happens in the round pencil case doesn't affect the square one. Then we can multiply the probabilities, and we get 15/56. See if that cancels down. So 15 over 56 equals, nope, stays the same. So the answer here will be 15/56. Okay, so that's how that question could be done. So filling in tree diagrams, guys, practice it. Touchwood, fairly straightforward, and just remember as you come and wherever you pick up along the branches you multiply, and if you need more than one of these as the true option to give you the answer they wanted, then you would work out each end and then add each individual probability together. Okay, so this question talks about different shapes on a grid, and it says write down the letters of pairs that are congruent. Now congruent means totally identical, can be a different orientation, so it can be rotated round, but if you cut one out it fit exactly over the other one. So congruent, we can see that D and B are both identical, so D and B are the congruent ones. The question then goes on and says which of these shapes are similar. Well, similar means that one's an enlargement of the other, so in other words every edge has been multiplied by the same scale factor. So when we look at this, we can see that G and E are an enlargement of each other, because 1, 1, 1, 1, 1, 2, 3, 2. And then when we go around this one, 2, 4, 6, 4, 2, 2, 2, 2. So in other words, everything's been multiplied by 2. So G and E are similar shapes. It says find the perimeter of D. So choose a point on the shape and then count round. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's on a centimetre grid, so the answer will be 16 centimetres. Okay, so that's a quick introduction to congruent shapes and similar shapes. Excuse me. This next question talks about two shell supports, and they're telling you that the two triangles are similar. Excuse me. Now, similar means enlargement, so we need a scale factor. So we look for two corresponding lengths on the triangles, and that allows us to find the scale factor. We can see that these two are on corresponding sides of the triangles. So why are they similar? Well, all angles in corresponding positions are equal. That's 60 degrees and that's 60 degrees, because angles in a triangle add up to 180. So that's how that question would be expected to be answered, and you had to show that's 60 and 60 as well. It then says work out the length of PQ. Well, we can work out the scale factor by dividing 20 and 15, so 4/3, and that means we multiply all these lengths on this triangle by 4/3 to get all the lengths on this one. It wants the length of PQ, so we're having to go the other way around. So we're having to come from ST down, so instead of timesing by the scale factor, we divide by it, because we're going from the big shape to the small shape. So we're going to do 10 divided by 4/3, and that gives us an answer of 7.5. So we show the workings, so we're doing 10 divided by 4/3, and then we get the answer of 7.5 centimetres. Okay, so this question again talks about similar shapes, and it's telling us we want to work out the length of LP, so we'll need a scale factor. So these are the two corresponding lengths, so we times by 9/6 the large length divided by the small length, and we get 1.5. So the scale factor is 1.5. It wants the length of LP, so this means we're going to take this length to get LP. So again, we're going to times by 1.5, so show the workings. So this will be 7.5 centimetres. It then says it wants the length of BC. Well, BC is this length here, so we're taking this length, but we're going in the opposite direction, so we divide by 1.5. So again, show the examiner what you're doing. So 12 divided by 1.5, so 8 centimetres. Okay, so basically we've recognised that similar shapes have an enlargement going on, and because it's an enlargement of all the lengths, the angles remain the same, of course, remember, so the angles don't change, just the size of the lengths. And we find the scale factor, and from the small shape to the big shape we multiply it, and if we go from the big to the small we divide by it. Okay, so this question again talks about similar triangles. So it's telling us that the angle PQR, so I'll call that theta because we don't actually know it, is equal to the angle PRS. So PRS, so that's theta. So my recommendation is that when you've got the triangles combined into a big shape, then draw the two separate triangles out. So if we draw the big one first, so we've got PRQ, and we know that's going to be the angle we've been told is the same. And we've been told that the length of PR is 5 centimetres, so we can put that length on. And then we draw the other triangle in the same orientation, but we know it's smaller. and we know that needs to be theta, so R was where theta was, and the longest side is going to be that one, so PRS. So this must be 5 centimeters, and that's 2 centimeters. Okay, so similar shapes, scale factor. So how do we turn that one into that one? Well, we times by 5 over 2, so that's the same as times by 2.5. The question wants the length of SQ, so we need to get the length of PQ first. So we're going to times by 2.5. So we're going to say that PQ is equal to 5 times 2.5, which is 12.5 centimeters. And then we notice that PQ is made up of PS plus SQ. So PQ equals PS plus SQ. And we know that PQ is 12.5 centimeters. We know that PS was 2 centimeters. So the thing that's missing is SQ, which must be 10.5 centimeters. Okay, so the answer to that question is 10.5 centimeters. Okay, so let's